BIOGEOLOGY, the open source investigation of rock formations that have multiple correlations to living tissue.
I've been living near this mountain that is known as the Elephant for the last 8 years, and when I saw these images I thought, maybe it's not just a mountain that looks like an elephant. Maybe there's actually more to it than that.
We might just have a severe case of pareidolia.
So some of these might just be rocks that take that shape, that form, but you never know. Some of them might actually be fossilized elephants.
Well, that is a good one.
And if that's the case, then everything we know about geology is based on erroneous thinking, and we need to start to revisit these different ologies. There are even people who suppose that giant trees existed that were, along the likes of Avatar, and a lot of this ties back into the mud flood idea, which is that there was once a major flood that swept across the entire world and covered up most everything living. This is a list of the different coincidences that I've compiled.
That's a lot of correlations, Mike. Let's start with Google Earth censorship, and then we'll share our primary observations going up the mountain, the cave resembling the eye socket, and the inner secret chamber that resembles the sinuses. But first, let's compare Mike's video of Google Earth in 2018 to this current Photoshop scenario.
The eye has literally been closed up. And it stays closed even as I move in right up next to the mountain. Now this is really odd because there's a whole section here that's been blurred out. Watch what happens as I get a little closer. Look at that. I zoom away.
The question is, why would they hide both the cave and the broken sections?
This area here is the spongeous bone that's been exposed, so the outer layer has fallen off. This is looking at a cross-section of the skull bone, and you can see that it looks like a sandwich. You have two thick layers of solid bone, and then this is known as spongeous bone.
So someone's been paid to paint specifically over these areas.
You have to get in right up next to it before this slowly disappears.
And the iron-rich interior appears to be at a uniform depth too.
And here, now you can see the ear portion properly, but as soon as I back away, and not very far, boom, it closes up.
Probably because there's a cave that perfectly resembles an ear canal. And that's just one of the 50 so-called coincidences.
So now we're up at the eye of Montgo, and if you look at this section here, that's the remains of the eyeball. Sounds crazy, but
we'll see it when we get a bit closer.
Yeah, and if you look, that whole section of rock there, and as we get up closer, there are all these clumpy rocks that are down below. If you look above, it's all a smooth surface. There's no fragmented areas in the cave itself. So the rocks down below haven't fallen from above. So then the question is, where did they come from?
Yeah.
And I believe that they are actually the petrified remains of the gelatinous substance that's in the eye, and also the backside of the eyeball is still there, as well as the optic nerve. And then this section here there's a channel going through. It's a cave.
Yeah.
And that is, if you look at elephant skulls,
There's a little hole right here.
and that's known as the infraorbital foramen, and all vertebrates have it. It's a blood vessel, or it's a hole that's in the maxillary bone, which goes through, and it permits blood vessels and nerves to pass through. Okay. So that's exactly where it should be located if this were an elephant skull. And then up there you can see that it's reddish. Actually look over here. You've got blackened areas, and then you've got reddish areas that are seeping down. And the venous blood, in other words the purple blood, that's the blood that's lacking oxygen.
So you could expect that to go purpley black.
That's darker, and when it petrifies, it goes black.
Yeah.
But the blood that's from the arteries, when that's exposed and it petrifies, then it's this reddish, rusty color.
Iron ore.
Iron ore.
This is the view from the bottom of the large cave, where I made a little observation of my own that I would like to share as it's a reoccurring feature in this mountain and others. In this little cave here, you can see where one rock is meeting another rock, and there's a clear crystalline quartz skin on this one, and there's another one totally separate onto this one. Now this doesn't explain rock being crushed together. It doesn't make any sense. Should be one layer if it was trickling down from rock that's been pushed together.
You can see that crack that's going up. All vertebrates have the eye socket that's made up of 7 different bones that meet in what are known as sutures. And if this is an eye socket, then what we're looking at here is the right eye, and we're looking at the inside of the right eye. And the bones are the frontal bone and the maxilla, and they meet inside the eye socket at a particular point. And that point where they meet is exactly where this line is. And the interesting thing about that line is if you look at it, you can see that it's 2 different kinds of rock, and they're meeting and almost overlapping a little bit.
Yeah.
And there's also a jog there. That line follows the exact same line of the inner portion of the skull of an elephant. So it's exactly where it should be. It looks as it should look.
As you can see, we're clearly well inside and well covered, sheltered. And back here, we've got another little cave. And if this was from water flowing, water always finds its lowest level. So I can understand the tunnels going down, but I can't understand tunnels going sideways and upwards. Okay, there's a channel going through to another cavity, and it seems like these are fractal biological, because they go up, they go sideways, and of course they go down as well. Okay.
You can see that there's really a tissue-like quality to it. So my theory is that, this would be artery vein passageway.
There's a number of areas where you get these deep holes that go in, and it looks a heck of a lot like blood vessels, and they're about the right size for the tissue. Here's another one. Again, here, this is that section of the mountain that's sticking upward, and this is what I think is a big blood vessel that was in the eye. This is an example of what may be the optic fissure, which is where the optic nerve goes. And on an elephant, it's here, and this is the exact same portion of the cave that we're looking at.
So you're looking at the suture again. Now we're looking upward, the top of the eye socket, coming down the other side of the eye socket, and right there is a crack and an opening, and that's the optic fissure. That curves down, and then it curves to the left there, and it meets that section where the optic nerve goes. We're looking down these channels whose names I've forgotten, but they match up exactly with the position and the angle that the bones meet in the inside of the eye socket.
Wow, that's a lot of coincidences.
And then right there, what you're looking at there, this portion here to the left, that is the optic nerve going down, and this whole section here is crystalline.
Pay close attention to this, because this whole back area here, and you can see the kind of lumpy, fatty nature of it, and here it's thinner, but here there's a large, thick portion, and then it becomes the optic nerve.
Are we filming?
Yeah.
Okay. So this is the back portion of the eye, this section and that section. You can see there's channels going in. and they break off into smaller channels. That's your blood vessels. And this whole back section of this entire rocky structure is covered with about a 10-inch thick layer of crystal. And you can see the crystal here.
Oh, yeah.
And you can see the layer. So that's consistent with what you would expect to find based on the structure of an eyeball, because the eyeball is very fatty in nature, and when fat petrifies, it becomes crystalline. So this is the other side of that big structure. So you have the eye socket, and then it's got a very, very biological feel coming down in these curves.
Yeah.
And then it's that section going down. That's the crystalline area that I was showing before.
Yeah.
And that's a chunk missing. So that used to be connected, and it connected to this, which is the backside of the eyeball. Get a sense of the blood vessels that are coming in. There's a lot of vascularity in the eyeball.
Yeah.
And up there as well. And then here you get more of that crystalline layer that's covering the whole back side.
Yeah.
And then on the front side, where there are large channels for the blood vessels on the part that's curving up, right in those areas, those are all lined with crystal as well, because blood vessels are made of fat.
Yeah.
And then this is really a great spot for seeing what the crystal looks like.
Yeah.
And the patterns. But you can see that it's lined like that. And what we see here on the entire back side of that structure is that there's about a 10-inch thick layer of crystal that's on top of another form. And this goes all the way around. So that's the optic nerve again. Looking over here, you can see the layer of crystal that's on top of another form of rock. Exactly how you would expect
and that's definitely different types of rock.
Yeah. And then if you look back
which
over
makes
here,
it very, very interesting.
Then this is that section of the inner the socket going down, meeting the optic nerve, and then there are channels that go down there. So you can follow that section down on either side. Those go down into the sinus passages, and if you follow these caves down and go in through smaller channels, that actually enters into a giant cavern in there that could very well have been the sinuses and maybe somehow leads to the brain.
So the tunnel gets darker as you get deeper into it. The floor is thick with dust, and the walls and ceiling show no signs of erosion from water flow. There are a few old ropes in the two steeper sections, and yes, it's both scary and exciting. But once you're in the main chamber, you'll find uniformed morphology and colours, making it hard to find a better explanation.
How many coincidences does it take before there starts to be a pattern that is emerging?
Yep.
And how many does it take before that pattern starts to be, highly unlikely unless there was some underlying reason for it?
So we're just coming out now. As you can see, it's quite deep. There was a rope, 2 ropes just down there. Well worth it.
Hopefully you are now convinced to go and look for yourself and to share your findings. We still have a few quick things to add. After all, we don't want you thinking that we just jump to conclusions. It's a big challenge to motivate people to verify something that conflicts with their beliefs. Have no fear facing the ridicule and sarcasm from the many people who are strong believers in what they've been taught. It is a shocking revelation, and a lot to take in at once. But that's the difference between keeping an open mind to anything unverified and falling into a belief system.
This picture looks like he's smiling. I like that.
This kind of rock here, in mainstream geology, they call it karst, K-A-R-S-T, and it's limestone that they claim has been eroded by rain and wind, and that's creating these fissures in these channels. And in titanology, what I believe is that this is actually the cortical bone above has been removed, and what you're exposing here is the trabecular bone underneath. So it's also known as spongeous bone, and it can be large channels or it can be small channels. It depends. Like in the skull, for example, the channels are very small, and it's called spongeous bone. Okay. But in the arms and the legs, the channels are bigger, and it's called trabecular bone. But it's essentially the same thing, and it's where the blood is produced. So mainstream geology would have us believe that these large channels that you're seeing of all different sizes going in all different directions.
Yeah, they're going in all different directions.
Yeah,
it doesn't make any sense.
Erosion.
This is the breathing passage, and this is also where the trunk connects. And it's a huge hole. This area here has all collapsed, and we can see that when we look from above. There's a major runoff here going down. So there's clearly been a major collapse of this part of the mountain. And that's exactly where I would expect there to be a collapse, is right where there's a big, giant cave. That would be the weakest point of the whole structure. Here you've got the ridge line of the skull. This has been maintained, but this is all collapsed. And geologists who study this mountain have actually talked about this curvature here. It's known as a synclinal. It represents a collapse of this section of the mountain. I'm thinking perhaps Montgo actually died of some kind of a giant head wound, and the blood and brains and whatnot oozed out the sides, and that's why the mountain looks the way it does. Now the interesting thing is, from this side you've got the same thing, another cutout here. So from above it really does look like an elephant's head turned slightly to the right with cutouts for the neck on both sides. And this would be obviously the spine. And if we look down here, this is a deep canyon, and it's perfectly placed for the separation between two legs, one here and one here. I studied chiropractic in school, so I've studied a lot of anatomy and physiology and histology, which is the study of tissues. And so looking at the books, I started to make a list of different features that I would expect to find. What we've been taught by geologists about the nature of rock is that it can't, about the nature of soft tissue is that it can't petrify, because the worms and the microbes will come and eat away at the flesh long before it could ever turn to stone, like a fossil that we see. And that is patently false, because you can bury tissue in mud, for example, and because it's an anaerobic environment that has no oxygen, the microbes and the larvae that would normally eat away at the flesh can't thrive. So the flesh just sits there for an indefinite period of time. And as it sits there, there's a slow exchange between the gases and the fluids that are in the flesh and the surrounding minerals in the mud around them, and they work their way in. And so that is the process of what's known as paramineralization. And we know that this happens because we know that, for example, petrified trees exist. And there are different pine cones around the world that exist that show very, very detailed, biological, anatomical features. So it's not such a reach, really.